Mathematical modeling. The modeling using mathematics is one of the most important applications of mathematics in daily life. More importantly, with the scientists, engineers, doctors, or any other branch of professionals who use modeling to predict certain things using mathematics. So what is mathematical modeling? Basically, what is that we understand with the word modeling? Is it about fashion modeling, or is it about the modeling with some other purpose of mathematics, understanding through mathematics? So mathematical modeling, let's start with a real life application as an opening problem. To start with the introduction, let me start with why mathematical modeling. So let me come with one of the historical fact where on 25th February 2013, ISRO launched PSLV C20 satellite called Saral into the orbit. We all know that through the Google search we can get the information on 25th February 2013, ISRO, which is quite familiar with launching many satellites in the space. One of the rocket has already been launched to land on Mars. The mission for Mars is credited to ISRO. So to start with, ISRO launched PSLV C20 satellite called Saral into the orbit. Now they have made very great mathematical calculations before they could launch this into the orbit. Say for example, if this is the Earth, imagine I have an Earth through which I would like to launch the satellite. So if I have the Earth out here, then in this case there is a satellite which is launched on from one place of the Earth. Sriharikota is mostly where we launch in India, because that is considered to be the excellent platform for launching with clear weather and clear atmosphere for prediction of the launching of the satellite. So when this was launched out, they have the mathematicians have predicted the modeling exactly by saying that this satellite, which is this rocket which has gone into the orbit, this is the orbit in which the satellite was put, and when the satellite was put here, this was 407 kgs of weight, and this was exactly 781 kilometers from Earth, and making an inclined orbit angle of which is approximately 98.5 degrees. Therefore, the turning angle or the orbit angle was calculated to be 98.5 degrees, and the height at which the satellite was put in the orbit was 781 kilometers from Earth, and the weight of the satellite was 407 kgs. So all the weight, the angle and the distance are very much related with mathematical modeling. How could the scientists in ISRO predict on the distance between the satellite and the Earth? Predict on the angle is what is mathematical modeling. How could they predict? This is the biggest question. Only mathematical modeling can answer this question. Similarly, you take the surface of the sun. As we have seen, the surface of the sun, as here, we have also the temperature which is measured using mathematical modeling. So let's see how the surface of the sun is also done through mathematical modeling. Now, the surface temperature on the sun is calculated to be 6000 degrees centigrade. How could the scientists predict on the temperature on the sun? Because going on to the nearest of the orbit of the sun itself is a greater task. It is impossible that we can reach even to near of the sun, because the temperature surrounding the sun is very hot. Therefore, how could exactly the scientists predict on the surface temperature of the sun is 6000 degrees centigrade is the biggest question which puzzles many of the commoners who read this. The answer for this is mathematical modeling. That is, if suppose I have a sun, we all know that the sun is very hot, that even when you enter nearest its orbit, also any satellite or any object melts immediately. Therefore, with this melting point, it is impossible that we go to the sun and measure the temperature on the surface of the sun. But that is done through mathematical modeling and predictions. And therefore, this also is one of the examples where the temperature is 6000 degrees centigrade on the surface of the sun, which is predicted using mathematical modeling. Now, next question which puzzles the mathematicians out here is heart pumps 5 to 6 liters of blood in the body every minute. If a biological science teacher is explaining about the functioning of the circular system, and then if the question comes on how many times does the heart pump, how many liters of blood does heart pump in 1 minute, then the answer is 5 to 6 liters of blood which is pumped every minute in the entire body. But how could the scientists or the doctors come to this accurate prediction? Did they cut the body out? Did the heart function when the body was cut? The person is almost dead. So how could that happen, that a heart is taken out of the body and measured through all the blood which is taken out and measured in liters? It is impossible if we imagine this through the direct predictions. But this was done through the mathematical modeling, where if I have a human body with then in this case I see that a heart is pumped. If this is a heart out here, then to different parts of the body the heart pumps. So as I see here, so here the quantity of 5 to 6 liters of blood pumped every minute is clearly a prediction through mathematical modeling. So now that we have seen different examples through which we connect mathematical modeling with the almost impossible solutions, like finding the surface temperature on the surface of the sun, or predicting the number of liters of blood we can have, or predicting the distance between sun and earth, where it is impossible to land on sun and measure the distance from sun to earth. These impossible predictions are almost made successful through mathematical modeling, where modeling connected with mathematics. How could that be done is the biggest question which we are going to discuss in the topic of mathematical modeling for the session. Now, continued with this, let's see some more interesting examples which we see in everyday life connected with mathematical modeling. To start with the game of basketball, we all know that a basketball is a very interesting game from all of the students. So let's see how mathematical modeling is done with the game of basketball. So this is a very simple activity which can be done even in the schools, because this is the most simple activity through which we can understand modeling through the practical or experiential learning. So let's take the game of basketball, where a person is just standing near the basket, or if I draw the basket out here, then on the ground I have this is the basket I have out here, then I have the ground from where the person is standing. So he has a ball here through which he would like to throw into the basket. Now we all know, say he is standing at a suitable distance of 10 meters away from the basket. Say for example, he is standing 10 meters away from the basket and he would like to make a D. Outside the D, he would like to just throw the ball. So in this case, he is just going to attempt on throwing the basket, not directly into the basket, because if the ball is thrown to the basket, it touches and bounces back. So the technique here is he first initially throws it in the air, and then that goes inclined at an angle into the basket. So this is how the ball goes into the basket and runs outside. This is how we understand the game of basketball. So therefore, the ball thrown into the basket is assumed with thrown out, up and down, and then inside. So what kind of modeling are we using here? Clearly, I see that this is an inverted parabola. So I see that this here is an inverted parabola. So therefore, if I just see on what different attempts I can throw the basketball, I can make a video recording of the number of times I throw the ball into the basket, number of times I throw it, and if on first attempt I fail, second attempt I fail, then finally the third or fourth attempt I am successful in exactly putting the ball in the basket. I video record the basket where the ball is thrown, and that different shape of the curve is taken into consideration where an exact basket is formed. But clearly I find this to be an inverted parabola. So this is an inverted parabola which we predict. Therefore, inverted parabola is nothing but we connect with quadratic function, because we have already seen in the topic of quadratics that a parabola is nothing but a quadratic function. So mathematical modeling of a game of basketball where I want to throw a perfect basket is connected with the best quadratic function which can fit, is how I understand the throwing of the ball in the basket. So with the final attempt on the exact basket, that curve decides on the best quadratic function which can fit for the given points. So if I take this on x and y axis, then I have this to be x and this to be y, and this on origin where the person is standing. From there I draw different points randomly out here, which gives me the exact modeling of the quadratic curve. So the points will give me the shape of the quadratic function which can fit, and this function will decide the best basket made. That is, the best where the ball falls into the basket is called best basket made, and which is purely done through mathematical modeling connected with real life. Now let's see the definition of mathematical modeling, which is finally concluded as the process of constructing a model and using it to describe and predict the real life situations. Therefore, mathematical modeling is used to predict and describe the entire model using mathematics. So let's see one of the example problem and understand how mathematical modeling is constructed using the basic real life problem. So one of the real life problem is that Vani wants to buy a TV that costs 19,000 rupees, but she has only 15,000 rupees with her. She is in short of 4,000 rupees more to buy a TV. So what she does is she decides to invest her money at 8% simple interest. So with an investment of 8% simple interest, she wanted to buy the TV, and the question is, after how many years will she be able to buy the TV? This is one of the most interesting questions which can be connected with mathematical modeling, because with the minimum information given out here, I should be able to find after how many years she will be able to buy the TV successfully. That is, after how many years she can reach the 19,000 rupees through which she can buy a TV. So let's see this through a stepwise construction on how the solution of this problem is obtained connected with mathematical modeling. To start with continued session. So the first step of constructing the previous example problem using mathematical modeling is understanding the situation. Any problem given is understood and visualized in real life situation. As clearly given out there, the principal amount in case of this is given to be rupees 15,000 because she invests the rupees 15,000 at the rate of interest of 8% per annum, and then the amount she has to get is given to be 19,000 because once she reaches 19,000 then she can buy a TV. Then in this case the number of years she has to pay the amount at 8% rate of interest per annum, I had to calculate after how many years she will buy a TV. That is, after how many years she will reach the amount of this is what is asked. This whole question asked under simple interest is what we identify or understand the situation. So mathematically, we understand the situation as finding the time when amount, rate and principal is given under the simple interest concept. The step 1 is understanding the situation in this manner. So in this aspect of the modeling problem, we try to give the mathematical description and formulation. That is, we define the variables. Initially, in case of these type of step 2 process of mathematical description and formulation, we define any variables which exist, and equations, we write equations or inequations if needed. So all these basic things are defined in case of step 2 of the population process, and we also formulate in case if any formula needs to be done. So formulating the problem is very important. So in this case, I have simple interest is PTR by 100, which I formulate where each of the variables are P, T and R are the variables, and of course even the simple interest are each of the variables which are identified here. And the equation is this, which is formulated with P being principal, T is time and R is rate of interest. But because I need to formulate for finding the number of years she needs to pay as rate of interest with 8% per annum to buy a TV, finally paying 19,000 rupees. Therefore, the number of years standing with T is identified as 100 times simple interest by P times R is what we formulate in the step 2 of the modeling problem. So step 2 is generally about formulating the mathematical modeling problem. Now let's see what is the step 3 process of the modeling construction. Now generally the step 3 of the process is the basic problems which we do in each of the contents of the sessions, like the exercise problems which we practice. So solving of real life problems is equally the same as we do in the class sessions. Now let's see how this solving this particular mathematical problem is done using the formulae. Now as I have P equals rupees 15,000 and my rate of interest is 8% and my amount is 19,000 rupees. Therefore, my simple interest is amount minus principal, which comes out to be 19,000 minus 15,000, which comes out to be rupees 4,000, and then I had to find T, the number of years. Therefore, my interest is 4,000 rupees and my principal rate and amount are already given in the problem. Therefore, using the formula as obtained in step 3, I get T equals simple interest into 100 by principal into rate is the formula. So substituting each of simple interest, which is 4,000 times 100 by principal, which is 15,000 times 8, I get 3 zeros which are cancelled, and then 4 ones, 4 twos. So 100 by 30, which is approximately 0 with cancelled. 3 threes are 9, 3.33 approximately, or this can also be considered as in the mixed fraction 3 1 over 3 is what I get when I simplify in the mixed fraction form, approximately this and this 3 1 over 3. Therefore, my time is 3 1 over 3 years, that is 3 years and 1/3 of 12 months, which is 4 months, which approximately gives me the time as 3 years and 4 months. This giving me 1/3 of a year is 1/3 of 12, which is 4. So 3 years and 4 months is the time at which Vani can successfully buy a TV. So step 4 is about interpreting the solution. That is, let's see how the given mathematical problem can be interpreted with its solution. Now that we have obtained the solution, that is time is 3 1 over 3 years, let's see how more realistic we can understand this solution, is what we understand by interpreting solution. As I can see this as 3 plus 1/3 of years, which I can see as 3 plus 1/3 of 12 this months and this in years. Therefore, this on simplification gives me 3 years and 4 months is what we get when I convert 1/3 of a year into months. Therefore, this gives me a more realistic information that therefore Vani can buy a TV after 3 years and 4 months when she can deposit with a rate of interest of 8% per annum of the principal 15,000 rupees. So therefore, Vani can buy a TV after 3 years and 4 months is the interpreting of the solution of the given mathematical model problem. So the last step of the mathematical modeling, that is step 5, is validating the model. So with validating the model, sometimes we check for trueness, it may not be true. So the problem which we have taken may not be always true if we change the variables. Say for example, in this case, I take the rate as 8% per annum, but if my second year the rate of interest changes, then the whole of the concept of modeling changes. Therefore, we assume that the rate is fixed at 8% per annum. So this is the restriction which we need to identify. Our model is very much true if the rate of interest is assumed to be fixed, at 8% per annum, because we don't know what are the predictions for next year. The different banks might change the rate of interest for every year. Say Vani might be paying more than 8% for the next year because of the change of banking rules. Then definitely this model may not be a perfect model for the prediction. So the limitation here is that we assume at 8% per annum for the rate of interest for the given mathematical problem. So that is how we describe all limitations here, one of the limitation being that it is assumed at 8% per annum. So validating the model includes all of what makes the limitations for the given mathematical model, is how we understand validating the model. Thus, a mathematical model could make us identify that Vani takes 3 years and 4 months to buy at last a successful TV using mathematical modeling, starting with step 1, step 2, step 3, step 4, and finally with step 5, which is validating the model. So mathematical modeling starts with each of series of steps through which we construct the given problem, the real life problem, which we solve using mathematical modeling. Now let's see, now that we have seen the mathematical problem connected with Vani buying a TV, let's see what are other advantages of mathematical modeling in real life, because simply real life is very big. There are many activities in daily life which use mathematical modeling, and therefore let's see a few of the most effective advantages of mathematical modeling in real life. To start with, the most important advantage of mathematical modeling is that it cuts on cost-effective experiments. That is, some of the experiments which you do directly are very cost-effective. They are very expensive. Therefore, say the best example I can give out here is studying corrosive effect of discharge of Mathura refinery on Taj Mahal. Now this is one of the biggest issue which has been affecting the archaeological department, because the polluted atmosphere of Taj Mahal surroundings has been polluting the Taj Mahal monument. The white and crystal clear white Taj Mahal has now been turning its color. The limestone, which was totally pure in white, has been turning its color because of the pollution effects of the discharge of the corrosive effect of discharge of Mathura refinery on Taj Mahal, straightly affecting the Taj Mahal. So the mathematical modeling helps us in cutting on cost-effective experiments, because we cannot experiment on Taj Mahal, because Taj Mahal is a very greatest monument in Indian history, which is one of the 7 wonders of the world, and hence we cannot disturb or we cannot spoil the Taj Mahal through experiments done on it. So indirectly we study the effects on Taj Mahal by mathematical modeling of the real life situation as one of the advantage. Similarly, we can predict tsunamis and earthquakes, cyclones, etc., which cause a lot of havoc, because the advantage with mathematical modeling is very important here, because we can save more number of lives, because if you know, we can predict a tsunami a day in advance or at least some hours before. We can alert the people nearby surrounding the tsunami affecting place, or near the seashores where the tsunami causes a lot of damage and lot of loss of lives. Therefore, predicting the tsunamis in advance, or predicting the earthquakes in advance, or predicting the cyclones in advance, usually the weather forecast tells us about, informs or warns us about the cyclones or tsunamis or earthquakes at seashores, and fishermen are restricted to go to the places for fishing inside the seas or oceans. Thus, the lives being saved in advance by predicting the tsunamis or earthquakes or cyclones using mathematical modeling. One of the greatest advantage which saves lives. The next is predicting future population of a country. Say for example, the population of a country is increasing by every 50 million or 10 million every year. Now the present population of India stands at 100 million plus. Now that shows on how we can take the controlling measures in controlling the population for future. So mathematical modeling definitely helps in predicting the future population of a country. If suppose I can predict the population of a country in 2028, then in 2014, that is in 14 years in advance, I can make some precautionary measures to control the population, or else everything goes out of control. The food scarcity, the land scarcity, and everything affects. Thus, we need to take quick measures on predicting the future population of a country and taking proper measures to control in advance. This is how we study the various advantages connecting the mathematical modeling. Very useful in real life. Now, next comes on discussing about limitations of mathematical modeling. To start with, a fair question which says, does mathematical modeling solve all our problems? Are we safe with mathematical modeling is the biggest question which can be put forth in this session. So the answer is certainly not, because all of the mathematical modelings are only simplifications of the real life problems. To start with, mathematical modeling is nothing but simplification of a real life problem. So definitely it has some boundaries or limitations which are restricted. Say, for example, if I model, I say the country and the map. Now comes the country and map. So a map of the country can never be a country itself. So map is the simplified process of the actual country. So therefore, definitely this might have its own restrictions with the actual problems existing in the country. So map has its own limitations or boundaries. Therefore, when we model the real life problem, definitely we take into certain boundaries or limitations. So limitations do exist for mathematical modeling. So the next question put forth here for limitations of mathematical modeling. Therefore, sometimes what we do is to improve the model or modify the data or modify, we include more data or information. But the limitations out here is that when we include more data, we get complex equations of solving. The solving of equations becomes more complicated, and then we need to take proper care in making it more simple and then defining for its trueness. So here the limitation is that complex equations to be made more simple and easy is how we understand, and then study the situations for the better model, because this particular modified model gives us more accurate predictions. Study the situations for more accuracy. Modifying the data helps us in accurating the predictions. The better the model, the better are the predictions we make, or more true are the predictions which make. So therefore, this also is one of the limitations which needs to be taken proper care with when we modify the data with this adding of the data and adding of more of the information. So with this, finally, we end the topic of mathematical modeling, and we come with the learning outcome that mathematical modeling is the most important application in real life. No mathematical modeling, no predictions in real life. Maths has got its more use in mathematics and other branches, and real life cannot survive without mathematics. We should be proud as mathematicians to study mathematical modeling and understand its applications in everyday aspect of life. So maths equal to real life is what I predict. In mathematical modeling, the equation is maths is equal to real life. No maths, there's no real life, and no real life, there's no maths.